because it shows how DHE can move beyond theory into real engineering implementation. So here we can see how the 5 DHE modules are integrated into the LNG system. Sensor in which embedded in the tank on the wall of the LNG tank continuously record structural and thermal behavior. And then this data are transmitted to an analytics center that the digital twin replicate the coupled behavior of the tank, soil and store liquid. So by using AI algorithm, the system diagnose abnormal vibration or pressure pattern that will potentially detect early sign of damage. And at the end output of the DHE, the model of predictive strength can estimate the remaining life considering multiple condition factor or the likelihood of leakage during the future earthquake estimation. So if enough data, it can detect corrosion factor like from the sensor. So the DHE also can simulate by using multiple condition to include also the corrosion factor into their output. So it depends on basically it depends on the training data of the AI itself. So what DHE can benefit to the LNG infrastructure? First, the system propose continuously track cryogenic effect. So it identify potential crack or leak through prediction model and provide operator with early warning. So this reduce downtime, enhance seismic safety, and ultimately extend the operational life of this tank. So the output can clearly save economic labor and production capability in a positive way. And then, so this is my research actually. So DHE for the rehabilitate corroded subsea pipeline. So this diagram give the overall picture of how digital healthcare engineering function applied to the rehabilitate corroded subsea pipeline, strengthened with fiber reinforced polymer system. So the process begin with on-site health parameter measurement. The data can be measured by, for example, corrosion tester, acoustic emission probe, and strain gauge in order to collect continuous data on the pipe mechanical and also the corrosion condition. Then this data are transmitted to onshore analytics center through low Earth orbit satellite or subsea fiber networks, where analysis simulation are carried out to reproduce its real-time structural state. So within the analysis, AI-driven diagnose and evaluate whether the degradation has reached critical threshold and whether the existing fiber and polymer repair remain effective. So if deterioration accelerate, the DHE system recommend rehabilitation action such as adding an extra FRP layer, increase the overlap length of the FRP, or performing localized pressure relief. So the final stage involve predictive health analytics, which estimate the remaining service life and automatically update maintenance schedule. So the DHE digital healthcare engineering transform the rehabilitation of the corroded pipeline into a closed loop digital healthcare system where sensing, analysis, and material repair act together to sustain the pipeline structural integrity and also the environmental safety. So we look on the predictive engine of the DHE system, which heavily rely on the artificial intelligence. So one of the AI in the brain of the DHE system. So in this framework, algorithm models such as artificial neural network analyze corrosion data from the on-site monitoring process. So it will identify wall loss pattern, the reduction of the thickness of the wall of the subsea pipeline, and early delimitation of the FRP web. So recurrent neural network and LSTM architecture study the time series sensor data like pressure fluctuation, strain history, or temporary cycle. The result is to predict how corrosion will evolve in the next month or years. So these AI models are trained on both historical maintenance record and also the real-time sensor input, meaning their prediction are continuously recalibrated through the digital twin feedback. So according to some research-related, such hybrid framework achieve prediction accuracy between 90% and 90% above for corrosion classification and less than 10% error in estimation the degradation rates. So the output of the predictive analysis directly inform rehabilitation planning. From that, we can determine when an FRP overwrap should be reapplied and how thick it should be and where stress concentration may trigger secondary corrosion. So all the data represent a transformation from traditional reactive inspection to autonomous precision guard maintenance. So that ensure both economic efficiency and also environmental protection. So that's what I developed in this study. From that innovation, we developed another AI that relate on the image categorization. So it's not a innovation or outcome of the study. We can innovate the study to yes, the pace of the digitalization is very fast. So we keep on innovate and to meet the require of the industry. It's a very fast pace of the industry.